Hello, curious minds! Dr. X here in our infection tube. Today we're diving into the frontline defenders of our body, the cells of innate immunity. These are our body's first responders when it comes to fighting infections. Let's meet these microscopic heroes. First up, we have the neutrophils. These are the most abundant type of white blood cells in your bloodstream and are among the first to arrive at the site of an infection. They're particularly good at gobbling up bacteria and fungi. Next, we introduce the macrophages. Their name means big eaters, and rightly so. Macrophages consume pathogens like bacteria, dead cells, and even debris in the body. They also send signals to other immune cells to join the fight. Moving on, let's not forget the dendritic cells. These cells act as messengers. After capturing and processing pathogens, they travel to the lymph nodes to inform T cells about the invader, essentially saying, "Hey, we've got trouble." Then there are the natural killer. Remember it as NK cells. They have a license to kill cells infected with viruses and even tumor cells. NK cells check for signs of infection, and if they find them, they release lethal chemicals to destroy those cells. Last but not least, we have the mast cells. Found in your tissues, they play a key role in allergic reactions, but are also important in defending against pathogens. When activated, mast cells release chemicals like histamine that can recruit other immune cells to the site. Remember, each type of cell has a unique and critical role in our defense system. They ensure that any unwelcome guests are dealt with swiftly and efficiently. So, next time you're feeling under the weather, think about the Cellular Warriors fighting for you. Now, Dr. Max will tell us more details about these cells. From where we start? From where? Yes, I found it, Dr. Max. Who are the first responders when an infection strikes?
Great question, Cella. First up, we have the neutrophils. They're the most abundant of the white blood cells in this city of life, always the first on the scene when danger strikes. They are drawn to sites of infection and inflammation by distress signals that are as diverse as they are specific.
Wow! What kind of signals guide them?
4 major signals cut through the noise, guiding our heroes: N-formal bacterial peptides, the powerful C5a from the complement system, the inflammatory mediator leukotriene B4, and the urgent call of interleukin 8. Each of these signals binds to specific receptors on our neutrophils, urging them forward.
What happens when they reach the infection site?
As they arrive, neutrophils spring into action in a dramatic display of phagocytosis. Like elite soldiers, they engulf invading microbes, which have been marked for destruction by the body's own forces, opsonized by complement C3 fragments and antibodies.
Do they just capture the invaders?
Not just capture, Cella. Inside these defenders, a powerful set of tools is ready for the captured invaders. Microbicidal mechanisms within neutrophils, such as alpha defensins, and the potent reactive oxygen species from the NADPH oxidase complex, make sure that captured microbes are quickly destroyed.
Do they have other tactics besides capturing these invaders?
Indeed, they use something truly extraordinary: Neutrophil Extracellular Traps, or NETs. These are networks of chromatin filled with antimicrobial proteins, thrown out to trap and kill microbes, preventing their spread. These nets are double-edged swords. While they are crucial in catching pathogens and even helping to form clots to contain infections, they can also, under certain conditions, lead to chronic inflammation and diseases like rheumatoid arthritis and atherosclerosis.
Sounds like a tough life for neutrophils.
Absolutely, Cella. The life of a neutrophil is short-lived but heroic. After their mission, they are cleared away by macrophages, maintaining the balance and ensuring that peace returns to the body city.
So, they play a bigger role than just defense?
Exactly, Cella. Neutrophils play a critical role not just in defense, but in the drama of life and health within us. Every day, these cells demonstrate a remarkable capacity to adapt and respond to emerging threats, ensuring our safety in the unseen microscopic world. To summarize, neutrophils are the most abundant and first responders to infections. They are guided to infection sites by specific chemical signals. Neutrophils engulf and destroy microbes through phagocytosis. They use microbicidal agents and neutrophil extracellular traps, nets, to kill pathogens. Nets can also contribute to chronic inflammation and related diseases. After their tasks, neutrophils are cleared by macrophages to maintain bodily balance.
As we continue our journey through the wondrous world of immune cells, Cella and Dr. Max remain engaged in a delightful and insightful dialogue. Together, they thoroughly explore the various defenders of the human body, discussing each type of cell one by one.
Dr. Max, what happens after neutrophils have responded to an infection?
That's an excellent transition to our next set of defenders, Cella. Deep within the bone marrow, the factory of life, monocytes are born. These versatile cells start a journey through the bloodstream, ready to transform into the body's alert protectors, macrophages and dendritic cells.
Where do these monocytes go, and what do they become?
As monocytes infiltrate various tissues, they undergo a remarkable transformation. In the lungs, they become alveolar macrophages. In the liver, Kupffer cells. In the bones, osteoclasts. And in the heart and brain, they evolve into specialized cardiac macrophages and microglia.
That sounds like a significant change. What role do these macrophages play once they transform?
These macrophages are not just garbage collectors. They are also skilled architects of immunity. In response to infection or cancer, these cells can rapidly multiply and differentiate into either warriors, M1 macrophages that attack and destroy invaders, or healers, M2 macrophages that repair and soothe inflammation.
Is that all they do?
There's more. The story of macrophages extends beyond the battlefield of infection. They are central to many of life's critical functions, including recycling iron for new blood cells and cleansing the brain from pathogens and debris.
How do they manage all these responsibilities?
In the skull and vertebral bone marrow, an army of monocytes and macrophages stands guard around the central nervous system, ready to defend and repair our neural circuits at a moment's notice. However, the power of macrophages is a double-edged sword. While they are indispensable in guarding against diseases, their activation can also contribute to chronic inflammation, leading to neurodegenerative diseases like Alzheimer's and Parkinson's.
It must be tough to maintain such power.
Absolutely, Cella. Furthermore, in the theater of the skull, giant cells formed by the fusion of macrophages showcase their might, retaining the ability to engulf and destroy large targets, a clear demonstration of their lasting strength. Yet in every hero's tale, balance is key. Macrophages must carefully modulate their responses to protect us without causing harm. It is a delicate dance of defense and healing, demonstrating the complexity and beauty of our immune system.
So I will summarize this time, Dr. Max. Monocytes transform into macrophages, adapting roles based on location, like alveolar macrophages in lungs or osteoclasts in the bone. Macrophages act as defenders by attacking invaders and as healers by repairing tissues. They handle essential functions like iron recycling and brain cleansing. Macrophages defend the central nervous system, but can also trigger chronic inflammation and neurodegenerative diseases. Their ability to form giant cells demonstrates significant destructive power. Balancing protective and harmful impacts is crucial for maintaining overall health.
That's fantastic, Cella. Your grasp of the material is impressive. It's always a pleasure discussing these complex topics with someone who understands the intricate dance of our immune system so well.
Thank you all for joining Dr. Max and me today as we explored the fascinating world of immune cells. We hope you found our discussion enlightening and inspiring.
Indeed. And remember, this is just the beginning. Next time we'll dive even deeper into the roles of other essential defenders like dendritic cells, natural killer cells, and mast cells. So make sure you tune in to continue this journey with us.
Don't forget to subscribe and like the Infection Tube, and please share this video with your friends and family. Your support helps us bring more of these informative sessions to you, and it ensures you won't miss out on our upcoming episodes.
We're excited to see you next time as we continue to uncover the secrets of our immune system. Your curiosity fuels our exploration, so keep those questions coming and stay engaged.
Until then, keep learning and stay curious. Thank you for watching, and see you in the next episode of Infection Tube. Goodbye.